And let's have a look now at number 2, which says supply the missing information in the following table. So again, the first one there, dealing with water, that's just an illustration. So the next one is with ammonia, which of course, as we can see, is NH3. What we've got there is the number of molecules. So our first step then is to go to work out the number of moles. So that's going to be equal to this number, 2.4 by 10 to the 24 divided by 6.022 by 10 to the 23. And when we look at that, that looks as if it comes out as 4. So our answer here would be 4 moles. Part B then, once we know the number of moles, well then of course we can work out the mass. So we need to get the molar mass, and that would be the mass of the nitrogen here. Well, nitrogen has got a mass of 14.1, and hydrogen has got 1.008, and we've got 3 of those. So we multiply all of those together then and multiply by our number 4 here, our 4 moles. This, of course, is the mass of 1 mole. So the mass then of 4 moles is going to be this number times 4, which of course comes out as 68. So we need to put that into our calculators to work that one out. The next one that we're looking at, as you can see, is methane. That's this one here. So what we've got is 24 grams of that. So our first step then is to work out the number of moles. Now, in order to work out the number of moles, if we're given grams, then we divide the mass by the molar mass. So that's 24 divided by the mass of carbon, first of all, which is 12.01 plus 4 times the mass of hydrogen. So we can put those values then into our calculator, and hopefully we get there a figure of 1.5. Once we've got 1.5, then what we're in a position to do is to work out the number of molecules. The number of molecules is going to be 1.5 times 6.022 times 10 to the power of 23. And I presume when we put that into our calculator, we get a value of 9 by 10 to the power of 23. The next one, as we can see, is carbon dioxide. And what we've got with our carbon dioxide is 4.4 grams. We've got its mass. So what we need to do is work out the number of moles. To do that, we divide the mass by the molar mass. So working out the molar mass, we've got, for carbon, we've got 12.01, and for oxygen, that's 16, and we've got 2 of those, as we can see. So when we work that out, we get a figure of 44.001 grams. We then divide that figure of 44.01 into this figure. So that gives us a figure of 0.1. Going back over here now to work out the number of molecules, that of course is 0.1 times Avogadro's number, which of course is 6.02 by 10 to the 23, and quite simply that works out as this figure here. Now, as you can see there, it's rounded down to 2 significant figures. The next one is butane, C4H10. That's called butane. And what we have this time is 0.25 moles of that. So again, in order to work out the mass, what we've got to do is to work out the mass of 1 mole. Doing that, we take carbon, which is 12.01, multiply that by our figure here of 4 plus 10 times our figure of 1.008. So that then comes out as 58.12 grams. So with that, we can multiply our 0.25 times this number, and that will give us then the mass of butane. So the mass then works out at that value. And when it comes to the number of molecules of methane, that's going to be 0.25 times 6.022 times 10 to the power of 23. And presumably that is correct there when it's 1.51 by 10 to the power of 23. Round down, as you can see, to 3 significant figures. So there we have question 2.